Okay, so we're continuing on talking about dividing polynomials. And today we're looking at what's called the remainder theorem. So yesterday we did this, everything came out nice and perfect. There was never a remainder, that's how you want division to be. But that won't always be the case. So let's start with our example here. And let's use our synthetic division. So I'm going to write down all my coefficients. So -3 for my x squared, 5 for my x, 4 is my constant. Since I'm dividing by -3, and I'm going to put +3, I've always put the opposite on the outside. Bring down my first term. So this is -3. And then I multiply. So 3 times -3 is -9. 5 minus 9 is -4. 3 times -4 is -12. And then yesterday, this always came out to 0 right here, but 4 minus 12 is -8. So -8 becomes our remainder. And what that tells us, before we do anything else, is that x minus 3 is not a factor for our original -3x squared plus 5x plus 4, which means 3 is not a solution, okay? Because we have this remainder left. So now what we can do with that is really we can just double check to make sure we did our math correctly here. So we're going to compare the remainder of -8 to f of 3. So we're going to take the same number that we just divided by, and we're going to solve the function at that value. So I'm going to replace all my x's with 3's, and then we're going to work it out. So 3 squared is 9, 9 times -3 is -27, 5 times 3 is 15, plus 4, this is 19. So -27 plus 19 equals -8. Not a coincidence, right? So anytime you have a remainder, assuming you did your math correctly, then the value of that function at that x value will always be that remainder. So even though we don't have a solution, it does give us a point on the graph. Like I know if I were to graph this, that 3, -8 is a point on the graph, which may or may not be helpful, but it's something. We didn't do this work for nothing. We know a little bit more about what the graph of our function would be, okay? But really, this is our big focus today. I don't know why it's scrolled up. So it's going to give you the function, and it's going to tell you to solve it at some particular value. So let's try one of those, and then we can apply it back to what we did yesterday. So this one gives us f of x equals x to the third plus 3x squared minus 7. Evaluate at f of -2. Okay, so -2 to the third power plus 3 times, plus 3 times -2 squared. We do this better, -2. No, that was right. Squared on the outside, sorry. Okay, then we evaluate -2 to the third power is -8. Remember, anytime you have an odd power, if your base is negative, your answer is also going to be negative. If you have an even power, -2 squared, that's always going to be positive. So 2 squared is 4, 4 times 3 is 12, so this is plus 12 minus 7. If I can, well, let's not combine negatives. Let's just do an order. -8 plus 12 is 4. 4 minus 7 is -3. So f of -2 equals -3, which means if we divided this out, our remainder should be -3. Now you don't have to do this. This is totally unnecessary. But let's do that. Let's check and see. So I'm going to rewrite this using synthetic division. And this also lets us practice something we didn't get to see yesterday. Because this one, it messed me up the first time I tried it too. I was like, why doesn't this work? Okay, so x to the third, that coefficient is 1. The coefficient of x squared is 3. Our constant is -7. But then you notice we skipped over something. We went x to the third, x squared, and then their constant. So even if you don't see the x term here, you have to include it when you do synthetic division. So we have to put 1, 3, and then 0 is our coefficient for x. Otherwise, your math won't work out. You have to have everything in order. You can't skip stuff. Okay. Since we solved for f of -2, that means we wanted to have divided by -2. And remember, our whole goal here, at the very end, we should get -3. So fingers crossed that I didn't just mess up this whole video. So I bring down my 1. -2 times 1 is -2. 3 minus 2 is 1. -2 times 1 is -2. 0 minus 2 is -2. -2 times -2 is +4. And thank goodness, -7 plus 4 is -3. Okay? So really all this is, the remainder theorem just says, if you divide a polynomial by x minus or x plus something, whatever you have left over will be equivalent to if you evaluated the function at that same time. Okay, so you'll always get the same thing whether you divide or if you evaluate at that point. Okay, and as we get further along, hopefully this information will become more useful than just, solving the questions on the day's homework. So try them out. We've got one more day of dividing tomorrow. So you get to see one new thing, one more theorem, and it'll be good for the week. All right.